In the training dashboard, you can view the losses and the accuracy metrics graphs that will update in real time as the training progresses. The orange line represents training losses, while the blue line represents validation losses. For losses, we typically look for downward trends, while for accuracy, we typically look for upward trends to signify good model training progress. We can use this to identify overfitting when the training losses continue to decrease, but the validation losses start to plateau and then increase. Some classes with large number of data points may mask the results on classes with fewer data points. So you can filter the metrics graphs by the class to assess model performance on individual classes. For example, we can see that the car class has a better performance than the pickup truck class. For a more visual approach on the model performance, we can see how the model is predicting on validation samples across the whole training process. On the left, we have an image with the ground truth annotations, and on the right, we have the same image with the model predictions. Initially, the model doesn't know how to predict, but as the training goes on, we see the predictions becoming better, indicating that the model is learning well. The confusion matrix provides insight into the model's behavior in predicting objects by quantitatively highlighting what kind of prediction errors are being made by the model. Ground truth classes are represented along the columns, while the prediction classes are represented as rows. You can move the slider to see how the confusion matrix evolves across the training process. In each cell, you can see, in this case, there's 100% of motorcycles that are predicted correctly as motorcycles. The Recommendations tab provides insight into what actions need to be taken to improve the model performance for each training. In the first section, we have the assets with the lowest confidence scores. It shows up to 12 asset samples where the model prediction confidences are the lowest. From this, you can identify patterns in these data samples that make it challenging for the model to predict well, and include more of such scenarios in your dataset so that the model has more data points to learn from. Next, we have the confidence score histogram. This shows a distribution of confidence scores at an individual class level, allowing you to assess the model performance at a granular level. In this case, you can see that the car class has many high confidence predictions, but for the truck with trailer class, we can see that a significant proportion of predictions have low confidences.